Welcome, everyone. My name is Michaela DeForest, and I'm a platform engineer for the ATS Group. We're located in Philadelphia, Pennsylvania in the USA, and we're a Zabbix partner. Since the release of Zabbix 6.0, we've put a considerable amount of effort into evaluating Zabbix's new integration for monitoring Kubernetes. Over the next 20 minutes or so, I want to introduce the features of this integration and how to install and use it. First, I just want to give a brief introduction to the services we offer at the ATS Group and how Zabbix contributes to creating solutions for our customers. The ATS Group operates under the 6 pillars listed here. We create infrastructure solutions to support the configuration of platforms and operating systems. We also lead the way in data protection, service management, and provide end-to-end consulting services to optimize hybrid and public cloud solutions. Zabbix contributes to our ability to fulfill these last 2 pillars. We use Zabbix to optimize our customers' resources and guide customers through their DevOps journey, which always includes monitoring solutions like Zabbix. So let me give a brief overview of what we'll talk about today. We're going to start off by going through the installation of components that are used to allow Zabbix to monitor clusters. Then we'll talk about the items and hosts that are created in Zabbix and how triggers execute to alert on changes to performance or status of Kubernetes objects. I'll end the presentation by giving a brief overview of the Prometheus pre-processing features of Zabbix and how they're used in the Kubernetes integration, and how it can be exploited to allow Zabbix to fulfill the same features and more as a Prometheus server. So let's start with the architecture and installation of the Kubernetes integration. Zabbix introduced an official Kubernetes integration at the beginning of 2022 in the Zabbix 6.0 release. The integration consists of multiple Zabbix templates and a Helm chart used to install agents, and a proxy within the cluster. Before you can start monitoring your clusters, you need to be running version 1.19 of Kubernetes or above in your cluster, and then as well as Helm 3. Helm, if you don't know, is a package manager for Kubernetes that makes it easy to combine multiple Kubernetes objects and make them repeatable across multiple deployments. With Helm, you can deploy an application with one command. Helm will be used to deploy the Zabbix agent Helm chart, which is maintained by Zabbix. You'll also need an existing Zabbix server that's on Zabbix 6.0 or above. Kube state metrics will also be installed by default with the Zabbix Helm chart. You can also use an existing deployment if you have one. Kube state metrics will also expose information about the state of objects in your cluster as an API endpoint. Like I just mentioned, the Kubernetes integration consists of a set of Zabbix templates and a Helm chart that installs the necessary Zabbix components. The first 2 templates listed here will be attached to hosts created in Zabbix. The rest will be attached to discovered components represented by hosts as they are discovered by the 2 main templates. I'll go into a little bit more detail about the structure of the templates shortly. This diagram is showing a generic model describing how this integration actually works in Kubernetes. I have left out some of the less important components here to make the diagram a little bit more readable. The Zabbix server can live anywhere. I wouldn't recommend necessarily putting it in the cluster that you're monitoring, but this is certainly possible. It could live in another cluster or be installed directly on a host. Any installation configuration supported by Zabbix is acceptable. Within the cluster you want to monitor, you'll need to install the Zabbix agent Helm chart. The chart includes a Zabbix agent on each node installed as a daemon set. It also includes a Zabbix proxy and optionally the kube state metrics deployment, which can be installed by the Zabbix Helm chart or separately. kubestate metrics is a service that generates metrics about the state of objects via the API server. On each node in your cluster, there's an agent known as the kubelet. The kubelet makes sure that containers created by Kubernetes are running in a pod by taking a set of pod specs that are provided and ensuring that the containers are running and healthy. Included in the kubelet agent is a process called cAdvisor. cAdvisor provides resource usage and performance characteristics of the running containers. The kubelet exposes these metrics through the API. In many cases, such as when you use a managed service to run Kubernetes, like AWS EKS or Azure AKS, the installation of the kubelet on nodes is done for you. You may not have easy access to modify the kubelet configuration in this case, if at all. Be aware that this may mean that certain metrics exposed by cAdvisor and collected by Zabbix may not actually be collected because some metrics are not turned on by default. The Zabbix agent uses a service account that can be created with many read permissions to allow full monitoring, or you may use an existing service account to restrict permissions. This will disable some of the functionality, but some users may just not be comfortable giving the Zabbix agent daemon set the full privileges needed. The Kubernetes templates in Zabbix collect data from the clusters in multiple ways. The Zabbix agent installed in each node, which can be active or passive, passes data on to an internal Zabbix proxy. The proxy can communicate with the Zabbix server. The Zabbix proxy uses HTTP agents to collect metrics from kubestate metrics and the Kubernetes API server in the control plane. This will require a service account for the service account that is created or used to be added as a macro to the templates. This is what the cluster role looks like. A cluster role defines the permissions that the service account running the pod has access to. As you can see, the Zabbix service account is only given read and list permissions for various endpoints. While it's ideal that you allow it to access, you can replace this with your own cluster role with fewer permissions if you need to. So these are the 3 steps to completing the integration installation. I'll outline some of the most important steps, but for more detailed instructions, you can go to this link I have here, zabbix.com/integration/Kubernetes. The first step will be to install the Helm chart, which installs the agent, the Zabbix agent, on all your nodes, a Zabbix proxy, and optionally kubestate metrics. The next step will be to connect the proxy to the Zabbix server. This is done via the Zabbix frontend and resembles the same steps as with any other proxy. Finally, we'll attach the Kubernetes templates included in the Zabbix 6.0 release. The official Zabbix agent Helm chart is available at git.zabbix.com in the Kubernetes Helm repo. Configuration is controlled via the values file. A values file is just the name for a configuration file used by Helm. The README in the Helm chart describes various configuration items. There are many options, but I'll just call out a few here. If you would like to use your own cluster role or service account to control permissions, you would use the RBAC and service account create options here. There are also options to use the created cluster role, but add additional rules to it. This may not be very useful when you first start out using this integration, but if you ever choose to add custom items later, you may need to add additional rules to access the metrics you need from a cluster. The chart allows you to include any environment variables available to the proxy and agent Docker images as documented on Docker Hub. Only the most widely used environment variables are listed in this README, but you can follow the same pattern to include any others specified in the Docker images READMEs on Docker Hub. The next step is going to be to connect the proxy from within the UI. This is done just like any other proxy under the Administration Proxies menu option. The name of the proxy should match the environment variable ZBX underscore host name in the proxy pod. Now let's go over the structure of the templates because it is fairly complex. These two templates in the center of the diagram should be connected to two individual hosts. Kubernetes nodes by HTTP is linked to a host to represent the cluster's nodes. It will discover nodes and create hosts for them with the Linux by Zabbix agent template linked. The Kubernetes cluster state by HTTP template is connected to a host representing the cluster state. This template can create hosts representing control plane components, including the API server, controller manager, scheduler, and kubelet for each node. Each of these components has a corresponding template linked to it, created during the low-level discovery process in the parent template. After attaching templates appropriately, you should start getting data from your cluster as well as new hosts representing control plane components and nodes. When setting up the templates, there will be various macros to define. The most important ones will be the API endpoint URL and the API token. The kube API token value is a base 64 decoded service account token. Assuming you didn't change the service account name, you can use the command here to get the key. Otherwise, you may just need to modify the service account name or possibly the namespace if you choose a different namespace for this Helm chart. Because we're running the HTTP request needed to collect metrics through a proxy that is running within the cluster we want to monitor, we can use the internal DNS names to access the API. In most cases, it'll probably look something like what I have here, https://kubernetes.default.svc.cluster.local:443. The rest of these macros are mostly around filtering. If you have huge clusters and are having trouble with Zabbix handling everything, you can try filtering down what you're monitoring. You can match on nodes, labels, annotations, roles, or namespaces using regex expressions. Now let's move on to the features and best practices for monitoring Kubernetes with the Zabbix integration. Zabbix discovers and creates hosts for cluster nodes. Each node has a Linux by Zabbix agent template attached to it when it's created. This will collect basic metrics, including CPU, memory, disk usage, and other items provided by the Linux template to describe the node. The cAdvisor included in the kubelet running on each node, you can collect metrics related to the individual pods. cAdvisor can be used to collect metrics such as average CPU load. In addition to the standard items provided by the Linux template, the Kubernetes templates include items related to the nodes. That includes items such as the CPU and memory actually available to pods on a node. The repo holding Zabbix templates includes a listing of all the metrics collected for the Kubernetes templates. Zabbix is still learning which metrics are important to their users, so I'd feel free to set up more items after you get comfortable with the templates and share what you can create. As a best practice for monitoring Kubernetes, you should be alerting on critical status changes within the cluster. For me, monitoring clusters has always been challenging. Kubernetes environments are dynamic and always changing, which makes traditional monitoring difficult. Monitoring solutions like Zabbix need to be able to respond appropriately to these changes. In particular, we want to focus on two different factors of the environment. The first is workload performance, which is supported by Zabbix through interactions with cAdvisor. And the second focus is availability of applications. Zabbix leverages kubestate metrics to collect configuration and state of objects in Kubernetes. This includes tracking CPU and memory limits and requests, state of containers, number of container restarts, and pod state. Triggers that are very similar to alerts found in Prometheus Alert Manager can take action on such events as replica mismatches for deployments, pods continuously crashing, and the status of nodes. For those that are currently using Prometheus, you should see equivalent triggers in the Zabbix environment to alerts you probably have set up in Alert Manager, but with the added benefit of Zabbix's extensive trigger actions and overall flexibility. Like I said before, Kubernetes can be difficult to monitor because of its dynamic nature. Low-level discovery in Zabbix is well suited to manage the constantly changing environment. Zabbix discovers nodes and represents them as two separate hosts. The first host monitors standard Linux items using the Linux agent template. The second host represents the kubelet running on each node and can collect data specific to the Kubernetes environment. Zabbix also discovers control plane components in environments with unmanaged control planes. Each component is represented as a host, and component-specific templates are attached to each. Within each host, Kubernetes objects such as pods, daemon sets, deployments, cron jobs, and jobs are discovered and removed as they change within the cluster. It's very likely that if you have clusters that are being monitored right now and you're not using Zabbix to monitor them, you're probably using some combination of the Prometheus server, Grafana, and Alert Manager. The Prometheus data model is heavily supported across the industry, especially in cloud-native applications. Fortunately, since Zabbix 4.2, Prometheus metric processing has been supported. Because this is an older topic and has been covered extensively in Zabbix blog posts, presentations, and videos, I'll keep this section brief. The most important thing to take away from here, though, is that Zabbix can support your current infrastructure, and you can continue to use Prometheus and take advantage of the widespread adoption of its data model. The Kubernetes integration for Zabbix actually uses the Zabbix Prometheus integration as well. cAdvisor and kubestate metrics both expose data in the Prometheus format. Zabbix allows for Prometheus pre-processing in order to parse metrics. Here's an example of the Kubernetes template using this feature. In this item that collects the total number of CPU cores for a node in Kubernetes, the Prometheus pattern pre-processing step is used to pull out the metric value named machine_CPU_cores, which has been provided to us from a master HTTP agent item that hits the cAdvisor endpoint. Zabbix has two different pre-processing steps related to Prometheus. There's the Prometheus pattern step, like I showed you, and Prometheus to JSON to convert Prometheus metrics to JSON format, which can then be processed further. For those of you that are not familiar with Prometheus metrics, I have included an example at the bottom of the slide. Lines beginning with a # specify metadata that includes help text and type information. These lines are followed by additional lines in the Prometheus data model, where the first key in the metric name with option labels can have optional labels specified, followed by the value and optionally concluding with a timestamp. If a timestamp is not included, it's assumed that it's equal to the time of collection. You'll be able to continue to use Prometheus node exporters and application metrics commonly exposed via a Flash metrics endpoint. Because Zabbix is so flexible, it treats Prometheus data just like any other data source and allows it to be parsed as such. So that's all I got. Hopefully this has given you a good overview of the Kubernetes integration for Zabbix. This feature hasn't even been available for a year, and I bet the Zabbix team would be grateful to get more feedback on it. And with that, I'm going to open us up to any questions.
Thank you a lot, Michaela. A tremendous presentation. Some of the questions that we had, you answered during your speech. We have a couple more pop up. Since this is your first Zabbix Meetup presentation, if you don't know the answer, then we'll just simply feel free to say so. We'll try and research it during the other speeches and answer it. Or maybe we can just point people in the right direction. And if you do, then you're welcome to answer. So I'll go through them one by one. First question is, does the template work if the Zabbix agent is installed on the server rather than on the cluster?
So yeah, it actually should work. The downside to that is that they're not being automatically discovered. That might not be a big deal for your setup, but you're going to have to do it a little bit differently. You'd probably either disable the discovery rule that's collecting the nodes so that it doesn't like try to collect nodes that aren't there, or that don't have an agent running technically, or you could modify the template. But you could set up the agents outside of the cluster. You'll get the Linux by Zabbix agent metrics just like you would have before. It's just that the template actually discovers them.
All right, thank you. Next up, I personally have no experience with this. Maybe you do. Will this work similarly on an OpenShift cluster? Have you tested this out?
So I haven't personally tested it out. We've actually discussed it recently at my company because that's coming up for us and we're about to have one to test out. So I don't have a concrete answer yet. I would imagine that it does. I know OpenShift has a few other objects that this template doesn't discover. So it's possible that you'd have to modify the template a little bit or add to the template. I assume it'll work, but I can't answer that for sure. I haven't tested it.
Thank you. Next up, you showed some Prometheus metrics and some templates that do Prometheus preprocessing. Are these templates with these Prometheus preprocessing steps available publicly anywhere?
Yeah, so the ones that I showed were a preprocessing step that's actually in the Kubernetes template. There's plenty of other templates that use Prometheus preprocessing. I can't name them off the top of my head, but there's plenty of them. And you can also create items with Prometheus preprocessing yourself.
Yeah, and like you said, there are also blog articles, not sure about videos, but I do know that we published a couple of blog articles when the feature was released with examples that you can sort of go by and then implement it for your own, exporters and whatever else you have for your applications. Next up, another case of not sure if you've tested it. What happens to the cluster host metrics when the Helm chart is deployed to EKS?
Yeah, so that is what we have tested the most. Most of our clusters are in EKS, and everything works perfectly fine. The one thing I'd say about that, and I can talk specifically to EKS since I've worked with it so much. EKS, if you're using managed node groups, you don't have access to to change the configuration on the kubelet and modify the cAdvisor configuration. So as far as I know people have asked about that and submitted bug reports. But some of the metrics that the template tries to collect from cAdvisor are not enabled by default, at least with EKS, managed node groups. So there are certain metrics that you're not going to be able to get. I'm not sure if there's a way around that. It's probably not that easy to do. Maybe that'll be something they'll allow in the future. And I think that's the same with some other managed Kubernetes platforms. And then the other thing to keep in mind is, since with EKS, you're not managing the control plane yourself, that's managed by AWS. So you're not going to discover the different control plane components. So when I listed the cluster state node or template, that template discovers the API server, the controller manager, the scheduler, but those are items that you don't have access to from AWS. I think they probably run them on like multiple on one machine, something like that. So those won't be discovered, and you won't be able to monitor those. But since you're not monitoring them yourself, it may not even be necessary.
All right, thank you a lot. That's all for now. If you guys have more questions, like I said, feel free to use Q&A. We may answer them in text throughout the meetup. And if they accumulate, we will dedicate 10-15 minutes at the very end of the meetup to answer them live. Thank you a lot, Michaela. It was a pleasure having you. And
Thank you.
hopefully we'll see you in other upcoming Zabbix events also. I think everyone appreciated it.
I hope so too.
Thank you.
Thanks.